inverses. The inverse of a function reverses that function. So an inverse, or a function and its inverse, are basically opposites of each other. And the notation that we use, we have f of x is our original function. The inverse, you put a -1 exponent right after the f. If you see a -1 exponent, that means inverse. So this would be the inverse of f of x. Kind of what that means, if your original function, if you looked at the table, all of the points on your original function, and you just picked out one of them, let's say the one you picked out was 2, 3. And then you have an inverse, you have its inverse, you look at the table of points on the inverse, it's going to have the point 3, 2. The x's and the y's are all switched. It's not negatives. The x's and y's are switched, which is exactly how we're going to solve and find the inverse. We're going to switch the x and the y. So I'm going to give you the original equation. You're going to rewrite it by switching x and y, and then you're going to solve to get y by itself. You're basically going to rearrange everything, get y by itself. So number 1, I have y equals -3x plus 5. First thing you're going to do is rewrite that and switch the x and the y. X equals -3y plus 5. You literally switch the letters in the equation, yeah. And those two functions are inverses of each other. But we never ever see it as x equals. We're going to rearrange it. It does not actually change anything. Just change the look of it. If I rearrange where everybody in here sat, you would still be in this room. You're still the same people. You're just rearranged. So we want to get this to y equals. So you solve it, just work it out like you're solving a normal equation. If this was a number over here, you're trying to get y by itself. What would you do first? Subtract 5. Now in your calculator, you can't go type in x minus 5. It's going to plug some random number in for x. We're just going to write down x minus 5 equals -3y. Then what? Divide by -3. So those cancel, and that does get this y by itself. Here's a little bit of an issue we run into. Somebody somewhere decided they didn't want a negative number in the denominator. They said it's not proper. So the easiest way you can just get rid of that negative, you can't just erase it and that's all you do. But if you change all of the signs, it's fine. It's essentially the same thing as multiplying the top and the bottom both by -1. So I want to make this a +3. I can make that a -5 and a +5, or -x, sorry, and a +5. The only reason we're doing that is because somebody decided that's the proper way to do it. So that leaves your final answer as -x plus 5 over 3. And then we're going to put equals, and we're not just going to leave it as y. I'm going to put f inverse of x. Or you could, because it started out with y equals, I just kind of pulled in f of x. You could put y with a -1 exponent, y inverse. I'm more worried about this fraction. Any questions on that?
What if it was like negative y equals negative 3x? When you flip them, would it be negative?
It would be negative x. You only switch just the letters. Every sign in front of it, every number in front of it stays where it's at. Just the x, just the y swap. Alright, so number 2. Let's do the same thing. We're going to swap the x and the y. So notice the squared stayed right where it was. Literally the only thing I changed was the x and the y. Nothing else moved. Any guesses on what step I might do first? Add 1. Very good. And we get x plus 1 equals negative y squared. So if you have this negative in front is the same thing as like negative 1 times y squared. So if you have a number being multiplied, you need to go ahead and get rid of that. So I'm going to divide both sides by negative 1. I'm going to go to the side and write this out. I'm just going to show you some of the math. Alright. Like I just said, we don't want to leave a negative in the denominator. So I can make this a positive, make that a negative. That turns into a negative. So this is negative x minus 1 over 1. Do you ever see a positive 1 just left in the denominator? No, it's not necessary. Kind of like we just don't put a 1 in front of an x. It's just assumed. So I don't need that at all. So this really is negative x, just negative x minus 1 equals y squared.
So if I have a negative attached to a variable, I can just flip all the signs.
Yes. Yep. Is y by itself? There's a squared. How do you get rid of the squared? Good job. And that does give me y by itself. So I have the square root of negative x minus 1 equals, you could put y inverse, you could put f inverse x. I really don't care. Any questions? Number 3. Go ahead and rewrite it so that you switch the x and the y. Carter, any guesses? If you're wrong, it's okay. What step I might do first? Yes, I'm going to add 3 to both sides. I get x plus 3 equals negative y to the 5th. Haley, what do you think I do next? Very, very, very similar to what I did in number 2. Divide by -1. Yep, because there's a negative in front of that y. Got to get rid of it. So this becomes -x minus 3 equals y to the 5th. Everybody know why this became -x minus 3. We don't want to just leave a -1 in the denominator. So I change all those signs in the top, which leaves that a +1 in the denominator, which is not necessary. You don't need to put that, it's extra. If you put it, it's not wrong. But you're never going to see it written that way on a test, on multiple choice, or anything like that. Okay. And then now I have a y to the 5th. Who's going to give me a guess at how I get rid of that? Yeah, I'm going to, number 6, that's called the 5th root. It's not the square root of 5, it's the 5th root. So to get rid of a 5th power, an exponent of 5, you do the 5th root. And vice versa. If you have a 5th root, you want to get rid of it, you raise it to the exponent of 5. So I have the 5th root of -x minus 3 equals y inverse or f inverse of x, whatever. Number 4, let's switch the x and the y. So this one, we have the square root of y minus 3, and then plus 2 is on the outside. You can't combine those at all. You can't make that negative -1, because something that's under the square root is kind of like stuck together with that square root right now. You can't just pull it out. But what I can do is I can get rid of this plus 2 by subtracting 2 from both sides. And I have x minus 2 equals the square root of y minus 3. Now, I still can't pull out that minus 3. Can't do anything with that. I've got to get rid of the square root. Once that's gone, then I can keep going. So how do I get rid of a square root? Square it. Raise it to the 2nd power.
Why did you square it?
So if I want to get rid of the square root on the right, I have to do the same thing to both sides for it to stay balanced. Now, I could make you actually do x minus 2 squared, which is not x squared minus 4. Remember, you would have to do x minus 2 times x minus 2, double distribute. For this lesson, when we're doing inverses, you can just leave it. You don't need to do all that extra right now. So this is just x minus 2 squared equals, now because I raised to that 2nd power, that got rid of the square root. So it's just y minus 3. fractions. The only thing left to get rid of is the minus 3. How do I get rid of a minus 3? Add 3. That plus 3, I cannot add to the negative 2 because that is all grouped together with the squared. You just write it on the outside. So x minus 2 squared plus 3. That's my inverse. The big thing is you, just like when you're solving equations, and I don't know if you were kind of taught this way, but when you're solving equations, you know, you learned about order of operations, PEMDAS, whatever you learn. When you're solving equations, you go backwards. So when you're solving, you would add or subtract first. That's why that's always the first thing we do. Then you multiply or divide. Then you get rid of exponent. You just kind of go in reverse order. So that's the big thing that's going to trip some of you up. Like in last class, some of the questions they were working on, they had an issue because they were doing their order of operations wrong. All right, number 5 and 6 don't have y equals. They have f of x equals. Something I told you at the very beginning of the unit, f of x and y are the same thing. So this is the same as if I would have just originally put y equals. It's the same. So you start out a problem when you're finding the inverse by switching the x and the y. Now, when you have a fraction on one side and you're trying to solve equations, there are a couple of ways to go about it. The way that seems to make the most for most people is to make this side a fraction, put a 1 under it, and then cross multiply. You learned about cross multiplying, you're used to that. So if you multiply, what's 4 or x times 4? 4x. And then if you multiply anything by 1, it's just the same. So 20 plus 3y. And then I can finish solving this to get y by itself. So we subtract 20. And what's my last step? Divide by 3. Do I need to change any signs?
No.
No, there's not a negative under there. If I changed all my signs, that would give me a negative, and then I'd just change them right back. So my final answer is 4x minus 20 over 3. Or you could put y inverse, whatever. Alright, number 6. Switch your x and y. Do you have anything on the outside that needs to be added or subtracted? That 5 is that's part of this radical symbol. Okay, it's the 5th root. It's not 5 times the square root. So it just is always tacked along with it. So nothing is on the outside that needs to be added or subtracted. So the first thing we got to get rid of is this fifth root. How do you get rid of a fifth root? Raise it to the fifth power. That's going to get rid of the fifth root. But if I'm going to do that to one side, I've got to do it to the other. If all you have is an x, you don't necessarily need to put that in parentheses. You can, sure. It's fine. It doesn't matter. X to the fifth equals y minus 3. And then the only thing left is to add 3. And I get x to the fifth plus 3 equals y